Hello everyone, my name is Ganesh Karanjkar and today we are presenting presentation on the topic of artificial intelligence in robotics with my colleague Samarth Kale under the guidance of RT Patil sir. This is the introduction of the artificial intelligence in robotics. So this data can helps build better machine learning and artificial intelligence models that robots rely on to become autonomous, making real-time decision and navigating in dynamic real-world environments. Industrial robots are typically placed in caged environments. A human entering that environment stops robots' movement for safety reasons, but limiting human robots collaboration prevents the realization of many benefits. Robots with autonomous capabilities would enable the cell and predictive to coexistence of humans and robots sensing and intelligence prescription in robotics application are important because the effective performance of robotic system, particularly machine learning and artificial intelligence system, greatly depends on the performance of sensors that provides critical data to the system. This is the information about artificial intelligence. What is the artificial intelligence? Definition: artificial intelligence is the ability of computer or robots controlled by a computer to do tasks that are usually done by humans because they require human intelligence and discriminates. Artificial intelligence refers to the simulation of human intelligence in a machine that is programmed to think like humans. The idea of artificial intelligence initially being by the computer scientist from 1943 to 1956, a model proposed by Alan Turing which is known as the Turing test. A Turing test is an algorithm that computes the data similar to a human nature and behavior for the proper response. These are the advantages of artificial intelligence. First one is the it defines as more powerful and more useful computers. Second one is the it introduces a new and improved interface for human interaction. Third one is the it introduces a new technique to solve a new problems. And last one is the it handles the information better than humans. Next slide is the growth of the artificial intelligence in the industries. In 2020, the global artificial intelligence software market is expected to grow approximately 54% year on year, reaching a forecast size of 22.6 billion US dollars. Artificial intelligence is a term used to describe a variety of technologies referring to the creation of intelligent software or hardware able to learn and solve problems. According to research from markets, the robotic in automation technology market will grow from about 270 million in 2016 to just under 4.9 billion by 2023. Next point is the pushing artificial intelligence processing for robotics to the edge. There are two main parts of machine learning: training and inference, which can executed on completely different processing platforms. The training sites usually occur offline on desktop or in the cloud and entails feeding large data sets into the neural network. Real time performance or power is not an issue during this phase. The result of the training phase is a trained artificial intelligence system that when deployed can perform a specific task, such as inspecting a bottle on the assembly line, counting, tracking peoples within a room, or determining whether a bill is counterfeit. The next point is the decentralized artificial intelligence model. The decentralized artificial model relies on highly integrated processors that have high performance processing capability to run machine vision algorithms, a rich peripheral sets for interfacing to various sensors, a way to accelerate deep learning interfaces. All these all of these capabilities also have work efficiently and with a relatively low power and small size footprint in order to exist at a edge. Power and size optimized interference engines and increasingly available as machine learning grows in popularity. These engines are specialized hardware offering aimed specifically at performing machine learning interference. Next point is the cobots. Human can't generally get near traditional industrial. Second one is robots while they are operating without peril. Third one is the cobots are in contrast designed to operate safely. Last one is the alongside humans moving slowly and gracefully. Next point is the logistics robots. Logistics robots are mobile units that operate in environments where people may or may not be present, such as warehouse, distribution centers, ports, or campuses. Logistic robots fetch goods and bring them to a packing station or transport goods from one building of a company site to another. Some are capable of packing and packing goods as well. From here, my friend Samarth will continue the presentation.
Thank you, Ganesh. So the next point is last mile delivery robots. In this type of robots, the packages are arrived to the doorstep of a buyer with the help of these robots. The problem with this uh, last mile robot is that it costs around 53% of a total shipping cost. So to make it more efficient, more researches are being done on where to implement new robotics automation. Considering the satisfaction of the customers delivery process, it's more expensive and time consuming. The next point is time of flight optical sensor. This sensor rely on principle of time of flight, where a photodiode is used, whether it can be a single or multiple, to measure the distance of the illumination. The reflected light from the waves or from the obstacles are compared with the transmitted wave to measure the delay which represents the distance. Some sensors can identify the distance of a robotic arm to a target and help in correct accurate positioning. The next point is ultrasonic sensor. The vision sensors may not work if the light is too dark or bright. So the ultrasonic sensors plays a key role in this type of applications. By transmitting ultrasonic waves and listening to the echoes that reflect back from the objects, ultrasonic sensor can perform excellent in both the conditions. Ultrasonic sensors are more reliable than optical TOF sensor for obstacle avoidance as it's not affected by the amount of light available. So these sensors are more preferred in the conditions where the light is too dark or bright, or there is a transparent object used in the applications. The next point is vibration sensor. The vibration sensors are used to identify whether the machine is working properly or not. It uses a piezoelectric sensor which detects the vibrations in the machine. It can help in preventing the accident in the working conditions, or it may also gives us a signal whether pre maintenance or preventive maintenance can be performed Using AI and ML, accuracy of these predictions can be taken to the next level. The next point is temperature and humidity sensor. These sensors are used to check environment of electronic components, including motors and main AI motherboards. In certain applications, motor draws a lot of power and heat up accurate temperatures. Monitoring protects motor from driven harder before hitting safety margin limits. In tropical climate zones, temperature and humidity sensors can predict dew points for electronic systems protections and predictive maintenance. The next point is millimeter wave sensor. This sensor uses radio waves and their echoes to determine the direction and distance of a moving object by measuring velocity, angle, and range. Millimeter wave technology enables designs that are 3 times smaller and half the weight of a LiDAR range finders. This lowers the bill of materials cost. The sensors can be mounted directly behind the enclosure plastic without any external lenses or aperture. The sensors are extremely rugged and can meet protection of 69K standard. So thank you everyone. So thank you sir for giving us the opportunity to present. Thank you.